We'll now continue our exploration of pandas by looking at other forms of accessing, because the square brackets weren't complex enough or powerful enough. As we mentioned earlier in the introduction of the overview of pandas, we also have lock and iLock that allow us to access row and column labels and also by integer position. So let's remind ourselves of the structure of the data frame that we're playing with, the elections data. So lock provides, as we said earlier, label-based access. So if I call lock, lock is an object, it's not a method, it's an object that we access with square brackets. So it's as if it was a subarray. These objects are called accessors within the data frame. And this is done for syntactic convenience, basically, because it allows us to use syntactic features in the data frame that would not be possible if it was a standard method call. And it looks a little bit more like we're indexing, but now we're indexing in a particular way. We're indexing in this case by label, and when we look at iLock later, we'll be indexing by integer position. So lock lets me pass a series of labels, in this case row labels and column labels. So in this case I can ask, what is for row label 0, 1, 2, 3, 4, what are the columns candidate, party, and year. So we're doing candidate, party, and year. We're skipping one column and we're actually dropping the last one. So we're doing whatever selection we want, and we can do this in any order we wanted. I could have said here 4, 1, 0, 1, 2. And this would work just fine. And I would get the row labeled one repeated twice, and I could also get and I could also get them in any order that I wish. So this explicitly pulls out individual rows, and it pulls out those the column data corresponding to those individual rows. So it's important to note that lock won't work with numerical arguments if we were using the election data frame that was indexed by year. Let's take a look at what happens here. If we use the one whose indices are years, then this kind of what looks like positional access isn't going to work, right? This is going to give us an error. And the reason is that in the index, even though these are numbers, in that index there are no numbers 0, 1, 2, 3, 4. There are, those positions exist, but the values there in the year, even if they happen to be integers, are numbers like 1980 and 1984, the years of the elections. So Pandas is saying, I'm not finding that data. There's nothing that matches what you're asking me for. Whereas, since they are integers, we could pass it numbers, but they would have to be numbers that are actually in the index. So in this case, we could use 1980 and 1984, and then, for example, ask for the candidate and the party. Now, lock does some interesting things. For example, it supports slicing, which is interesting for labels, because labels are not intrinsically ordered, right? And so it does support slicing, but the slicing behavior is different from the slicing behavior of the standard square brackets and of the rest of Python. So it's important to take a minute here and explain what's happening. The slicing behavior in this case is inclusive, meaning that even for a numerical slice, because it's treated just like a label, then the behavior of the slices is basically what you're telling Pandas in this case is, find me the first occurrence of this label, and find me the first occurrence of this label, and give me everything in between those two rows. Find me the first occurrence of this label in the columns, which, as we said, they could in principle, there could be repetitions, and find me the first occurrence of this label and give me between those columns, right? So find me those columns, find me those rows, and give me everything in between. And because it is label-based, it really does make more sense. There is no notion of intrinsic distance between these things. The numbers don't mean anything. So it does make sense that you say, I want to grab from candidate to year, give me those columns. It would be very weird if the behavior was find me this one and give me the one before it, whatever that happens to be, right? And so Pandas made the design choice to say when you use slicing in lock, because the semantics is label-based, then we're going to sort of break convention with Python's standard behavior that slices are always interpreted as open-ended intervals, and we're going to give you a closed interval. So it is a bit of a peculiarity to keep track of, but there's sort of a good user experience reasons for having made that choice. So you can, for example, say on the one indexed by year, you could say give me from 1980 to 1984, and you will get all of those years. Again, this is not interpreted as a Python positional slice, but as a label slice, right? Now, by now, this should not be a surprise that if you pass, instead of a list of column names, you pass a single column name, you get the same behavior, but you get just the bare series. You don't get a data frame. And that if you wanted a one column data frame, all you need to do is wrap this call into square brackets and you'll get a one column data frame. Okay, that should be pretty familiar to you by this point. So if we only ask it for one row, right, what we get is a series, but now it's a series that corresponds to a row of the table. So let's take a look at what happens when I say lock and I ask for row 0. It's going to find me the row labeled 0. Let's remember the elections one has an integer index, and I can still ask for a set of columns, for example, from candidate to year. So it's going to be these columns, but it's going to give me that row alone as a series. So now this is a series where every element is of a different type. And this is why Python has to use the opaque data type object, which basically says it can be anything and they can be, the actual data in them can be different. Whereas if we, as usual, if instead of one integer we pass a one integer list, we get back a data frame. It's the same information, it's the series, but now converted into a row series, and we effectively get back a one row data frame that contains the same information that we saw here in the head. Now, if we don't give columns, lock will by default, just like think of a two-dimensional NumPy array, if you index it by rows, you get all the columns. Same thing happens here in Pandas. If I say give me by positional label, the rows labeled 2, 4, and 5 in the index, I get basically the whole data frame, those rows. I get all the columns. And just like we saw already, the usage of Boolean masks, you can ask lock to give you rows and columns with a mask, but this is the row mask, and this is, let me make it here, column mask. So in this case, I'm saying give me these rows that meet this, give me these rows, the subset of rows, the ones that happen to be where this happens to be true, and give me column the first, 1, 2, 3, the fourth, and the fifth columns. And this works perfectly fine. Now, if you have seen previous versions of the course, or you have an older version of Pandas installed prior to 0.25, it turns out that you could pass shorter masks here, and Pandas would basically fill in the remaining values, assuming they were all false. That was changed, and I have a link here to the discussion in the Pandas development GitHub site of why and when they made that change. But it was changed in the summer of 2019, and so today these masks have to be the correct shape. So in this case, our data frame has 23 rows and 5 columns, and the masks have to be 23 long and 5 long for the row and column mask. So this is an example of passing a list where we're actually getting a couple of rows and a couple of columns. So lock is probably the most useful and explicit and easy to wrap your head around accessor in Pandas, because given that it's label based, it's very explicit. The code you write is very explicit. It doesn't depend on the exact ordering of your data, and it lets you operate on rows and columns indistinctly. And finally, you can mix and match. So you can mix, for example, on the row of a Boolean mask and on the columns, but let's make sure that the mask is the correct size. Let me fix that. This was an older version of these notes that had. So I can say, give me rows, but give me in the columns, give me a column slice and a column label slice. and this works perfectly fine. We're selecting those rows that happen to be true, where our mask was true, and then we're saying from candidate to percent vote, give me those columns, and again inclusively. And so what happens if both the row and the column argument is scalar? If you give a single row entry and a single column entry, well, let's take a look. What you get is that value, is basically that cell, and now you get a standard Python value. So you get just the value. Think of it in, if we go back to here, what we're saying, oops, I want to view the table. In here, what we said was, actually, let me get away from single document mode for a moment. So in here, what I've done is I said, give me row indexed 0 and the column candidate. So the row indexed 0 is the first one, and the candidate is Reagan. It's this one. So let's say that I wanted to get this particular value. This would be row indexed 15 and percent. So if I say 15%, that will give me 48.3, right? So we're going to take a pause here. This really is a good time for you to practice with these things. This is definitely not the kind of thing that gets in your head in a single shot, and for you to complete the quick check to make sure that these ideas are clear in your mind before we move on to positional axis.